joined. So in the last class, we have discussed about the architecture, that is the layered architecture and cluster architecture we have seen, right? So we have seen the algorithms also, right? So already I told you that is the functional architecture, it is tier type, right? So tier 0, tier 1 and tier 2, then internet, right? So here this tier 1, sorry, tier 0, all nodes are homogeneous nodes. You know what is homogeneous and what is heterogeneous, right? So all nodes are homogeneous, that is the same configuration. Okay, and the purpose of tier 2, that is computing and processing. The purpose of tier 2 is computing and processing. So tier 1 is computing and processing, tier 2 is delivering the information to the sink node. So if you see here, this diagram, this is tier 0. So all the nodes are giving the information here, right? So from tier 1, this is going to tier 2. So tier 2 is sync node, that is communication node. So this will, what to say, fuse or process or compress the data and send the information to the internet. So from the internet, the user can get the information. Okay, so this is the functional architecture of the wireless sensor network. So architecture will be having 3 tiers: tier 0, tier 1, tier 2. Tier 0 is nothing but sensing the information, okay, and tier 1 computing or processing the information, and tier 2 is delivering the information. Tier 2 devices will deliver the information to the user or internet. Okay, so the components of the functional architecture: hierarchical clustering, last class we have studied. So this hierarchical clustering is for energy efficiency and scalable operation. Already I told you what is scalability of the network, right? That is, the network should be able to accommodate new nodes, or it has to able to give way to the node move from this particular network to other network. Okay, sometimes the node may be dead, or sometimes the node may be some nodes, new nodes may join. So our network should be in such a way that it should accommodate all the other nodes also. That is nothing but the scalability property of a network. So the components of the functional architecture, it has the hierarchical clustering, location awareness, and attribute based naming. So hierarchical clustering, it's mainly for energy efficiency and scalable operations, and location awareness, that is, in a particular network, 1 or 2 nodes may be equipped with the GPS to find out the location where that particular nodes are situated. So this location information will be given to other nodes also, so that all the nodes in a network will be able to know in which part that particular network or particular node is situated. Okay, that is location awareness. So mainly for location awareness, we'll be giving GPS or optical trackers. So all the nodes will not be provided with GPS. In the previous class itself, we have seen, right? So in a network, 1 or 2 nodes will be provided with the GPS facility, so that that particular node can able to identify its location, and this location information will be shared to all the other nodes in the particular network. Okay. So this is about the location awareness. And the third one is attribute based naming. Example, that for what particular operation the particular sensor was designed. So here it's temperature, and location it is northeast, and now the temperature is equal to 103. Likewise, the information will be given. That is attribute based naming. Okay, and the cluster head, already I told you, in a wireless sensor network, a small group of sensor node formed a cluster. That is, small group of sensor nodes will be forming a cluster, and each cluster should have a coordinator, right? Each cluster should have a coordinator. So this coordinator can be called as cluster head. Last class itself, I told you how to elect the cluster head. So the cluster head selection has impact on the network lifetime. So the cluster head should be reachable in a single hop. from their cluster members. So assume that this is the cluster head. Okay, here this green is the cluster head. That means this node with a single hop, it should reach the cluster head. Okay, here it is cluster head. Every node should reach the cluster head with a single hop. Okay, that is the condition. Okay, so cluster head should be reachable in a single hop from their cluster member. So these are the functions of the cluster head, the primary functions of cluster head. That is, the cluster head will aggregate the data from the respective sensor node and transfer to remote processing element. Then localization of a network traffic. Then channel implementation. Okay, that is to identify the channel. Yesterday itself we have seen channel assignment and channel scheduling, right? So channel implementation and network management, and also it has to check whether the battery is, that is the battery life is good. Suppose the battery life of this battery, that is the energy of this particular cluster head, is lower than any of the energy in the any of the nodes energy, then immediately the cluster head should withdraw from its position, and that node has to become as a cluster head. Actually, within the group of cluster, which node has more energy, that node should be acting as a cluster. Okay, so why the energy is draining, in the last class itself I told you, that is the cluster head is active all the time, right? So it will have some work or other to do, but this other nodes, whenever there is a data to transmit, it will be transmitting. Other time it will be in the sleep condition. Okay, so when the node is in the sleep mode, the energy is not drained. Okay, the energy is saved. So when the node is in the operating condition only, the energy will be reduced. So since the cluster head is in operating condition for a more time, the energy may drain. So the nodes with the high energy will become a cluster head. So in the last class, this is about the architecture. And in the last class itself, we have seen about the, I told you that I'll tell you about this data decimation in the next class, right? So data decimation is a process by which queries or data are routed in the sensor network. Sometimes the queries or data has to be routed in the sensor net. Not sometimes, always the queries or data has to be routed in the sensor network. So the data collected by the sensor node has to be communicated with the interested node. Okay, that the node which is interested node is called a sink node, because the sink node is interested to receive the information from all the nodes. So here the interested node is nothing but the sink node. Okay, so whenever data is collected by the sensor node, it has to be communicated to the sink node. Okay, sink node. So the node that generates the data is called source. Okay, so that is the node which has the information to transmit. That node will be called as source. Okay, and the information to be reported is called event. The event is, the information has to be reported. That is called event. And the node which is interested in that particular event is called sink node. Okay, so these terms you should be thorough. That is the node that you know, right? The node which generates the data is called source, and the information information to be reported is called event, and the node which is interested in an event is called sink. Okay, so this data decimation, it consists of two steps. One is interest propagation and data propagation. Sorry, interest propagation and data propagation. Here now it is not data decimation, data propagation. Okay, so interest propagation is, for every event that a sink is interested in it, it broadcasts its interest to its neighbor across the network. Okay, if the sink node is interested in particular event, then that information will be sent to all the nodes in a particular network. Okay, that is called interest propagation. Here the interest of the sink node is propagated by the sink node. Okay, and next one is data propagation. Data propagation is nothing but the nodes, normal nodes in a network, right? So when an event is detected, The nodes will be event in the sense some incident. Okay, some information is detected by a node, the information has to be reported to the sync node. That is called data propagation. Okay, so two steps of data decimation. One is interest propagation and the other one is data propagation. Okay, please change this as data propagation. uh, okay, so interest propagation and data propagation. So interest propagation is nothing but the sync node is transmitting his interest. Sorry, sync node is transmitting its interest to all the other nodes in the network, so that these nodes will be collecting the information about the information about that particular event, and it will be sending the information to the sync node. That is interest propagation. And data propagation is nothing but normal data transfer. That is, when any node receives some information regarding that particular network, that information will be sent to the sync node. Okay, that is called data propagation. Understood the difference between interest propagation and data propagation? Yes? The difference between interest propagation and data propagation? Please respond, ma. Jovin? Jovin is here? Just anyone you respond whether you have understood or not. Yes, thank you, ma. Thank you, Abhishek. Thank you so much. So this is the two steps involved in data decimation. So here the data decimation, it has flooding, gossiping, directed diffusion, data gathering, direct transmission, etc. Okay. So flooding is each node will be flooded with some packets. Okay, so each node receives more packets like queries, data, like it, like that. Okay, so each node which receives a packet broadcast it if the maximum hop count of the packet is not reached, and node itself is not the destination of the packet. Actually, flooding is nothing but just disturbing the uh, network operation. Okay, so it will be flooded with more data, so the wanted information will not be able to transmitted. Okay, so disadvantages: implosion, overlap, and resource blindness. The disadvantages of flooding is implosion, overlap, and resource blindness. So implosion is the situation when duplicate messages are sent to the same node. Okay, same node is receiving the same message several times just to flood that particular node. Okay, so that is implosion. Implosion is the situation when duplicate messages are sent to the same node. Okay, so this occurs when a node receives copies of the same messages from many of its neighbors. Okay, that is implosion. Then overlap: the same event may be sensed by more than one node due to overlapping regions of coverage. So this results in their neighbors receiving duplicate reports of the same event. Okay. So resource blindness is due to the flooding protocol uh, does not consider the available. So actually, while transmitting a data, while finding the path, 1 minute. 1 minute, ma'am. Sorry, ma, some important call regarding network. That's why I have attended. So we have seen about this flooding, right? So the disadvantages of flooding is implosion, overlap, and resource blindness. Implosion, already I told you, this is a situation when duplicate messages are sent to the same node. Okay, and overlap is nothing but the same event may be sensed by more than one node due to overlapping regions of coverage. And the third one, resource blindness, is the flooding protocol does not consider the available energy because actually while finding the path. Okay, that is, if any node wants to send some information to some other node, it has to find the path first. Okay, while finding the path, they will be checking the node's energy. Okay, whether this particular node will be capable of transmitting this information, whether it has energy or not. Likewise, it will be it will be checking the energy level of each node, and based on the energy level only, it will be taking the path. But in the resource blindness, the flooding protocol, it will not consider the available energy of the nodes. Okay, so it results with many transmission. The same packets may be transmitted many times. That is called redundant transmission. So because of that, the node's lifetime will be reduced because the energy will be drained. So the node's lifetime will be reduced. If the node's lifetime is reduced, naturally the network's lifetime is also reduces because collection of nodes are network, right? So this is the another one disadvantage. So flooding disadvantages are implosion, overlap, and resource blindness. Next is gossiping. Gossiping is nothing but the modified version of flooding. Okay, gossiping is modified version of flooding. That is, the nodes do not broadcast a packet, but it sends it to a randomly selected neighbor. Okay, that is, it will not broadcast in the sense all the nodes will not receive the information. Randomly, some nodes will be selected and it will be sending all the packets there. Okay, so and another another work of this gossiping is it takes long time for message to propagate throughout the network. Okay, and also it will not guarantee that all nodes of the network will receive the message. Okay, so this is called gossiping. Gossiping is another version of flooding. It will not broadcast the packet. If it is broadcasting, that means all the nodes in the network will be receiving, right? You know the difference between broadcasting and data transmission, right? Broadcasting is once the information is transmitted, all the nodes will be receiving it. Okay, instead, in gossiping, it will select the nodes randomly and it will send the information to that selected nodes alone. Okay, that is gossiping. So then direct diffusion. So direct diffusion protocol is useful in scenarios where the sensor node themselves guarantee request queries for data sensed by another nodes. Okay, so each sensor node names its data with one or more attributes. That is three. One is hierarchical clustering, location awareness. Then the third one is attribute-based naming. So in the attribute-based naming, we need to give names. Okay, each sensor node names its data with one or more attributes, and each sensor node express their interest depending on these attributes. Okay, so each path is associated with the interest gradient. While positive gradient make the data flow along the path and negative gradient inhibit the distribution data along the particular path. Okay, two types of gradient, positive gradient and negative gradient. So positive gradient make the data flow along the path and negative gradient inhibit the distribution data along a particular path. So data gathering. So the objective of data gathering problem is to transmit the sensed data from each sensor node to a base station. So for data gathering algorithm, these are the main goals. So while gathering the data, we need to maximize the lifetime of the network. Then the energy consumed should be reduced and the data transmission has to occur with minimum delay. Okay, that is the objective of this data gathering algorithm. Okay, the objective of data gathering problem is to transmit the sensitive data from the sensor node to base station, and also while transmitting the node has to the network lifetime has to be maximized. How the network time can be maximized? If the energy consumption is less, naturally the lifetime of the network map can be maximized. And also the data has to be transmitted with minimum delay. Okay, suppose if I am talking and you are receiving each word after 5 seconds or after 10 seconds, then it is not a proper data communication, right? As and when I am talking, at the same time you will be able to listen it, then the data transmission is proper, right? So the data transmission has to occur with minimum delay. So this is about data gathering goals. Next is direct transmission. So direct transmission is all the sensor nodes transmit the data directly to the base station. So this is cost expensive, right? It's because the sensor nodes are very far from the base station. That's why we are putting one sync node in between. So all the sensor node will send the information to the sync node, from the sync node to the gateway, right? So it is cost expensive when all the sensor nodes are, because all the nodes are very far from the base station. So nodes must take turns while transmitting to the base station to avoid collision. So if it is direct transmission, then the media access delay is large. So this direct transmission performs that is poor efficiency. That is, direct transmission it performs poorly with respect to energy efficient algorithms. So next is, this is separate unit. We'll be studying it in the second or third unit, MAC protocols for sensor network, but little I will tell you. So the challenges posed by sensor network MAC protocols are no single controlling authority. So global synchronization is difficult in the MAC protocols, and power efficiency issue will occur. Then frequent topology changes due to mobility and failure. Because then sometimes I told you the nodes are static. Sometimes there will be mobile nodes also. So due to mobility, if some nodes move out of that particular network, because of that the topology will change, right? Topology is nothing but the way in which the nodes are arranged in a particular network. Okay, and due to node failure also the topology may change. So frequent topology changes will be occurring. And there are three kinds of MAC protocols used in the sensor net: fixed allocation, demand based allocation, and contention based allocation. Fixed allocation is the path is fixed. Okay, three kinds of MAC protocols. Fixed is once the resource is allotted only. We cannot change it. Then demand based. Whenever you ask, I will provide. Likewise, that is demand based. And contention based is nothing but depends on the traffic. Okay, so if this particular route is congested, then we will be finding some other alternative. Okay, that is contention based. So everything we will be studying it in the coming units. Okay, there is one unit for MAC protocols for sensor network. In that we will be studying it. Okay, so with this your architecture is over. Next is time synchronization protocol. Next topic is time synchronization protocols. I'll upload that PPT. Next is time synchronization protocol. Are you able to see? Yes?
Yes, ma'am.
Okay, thank you. One minute. I couldn't. 1 minute. So this time synchronization protocol, actually, the wireless communication, the technology, wireless communication, actually it advances and the cost of manufacturing of sensor node continues to decrease because the cost is continuously decreasing. So, a low cost but powerful sensor network may be deployed for various applications that can be based on our daily life. Okay, so a sensor node seems to be much less capable than traditional stationary sensor, and the collective effort of the sensor nodes provide sensing capability in space, time, and space, time, which exceeds the capacity of the stationary sensors. We have some stationary sensors also, but okay. So the communication protocols for sensor network may have the capability of collective efforts. Okay, to have the capability of collective efforts to provide the user with specialized applications. Okay, so the purpose of this this protocol, okay, that is time synchronization protocol. The purpose of this time synchronization protocol can be it can fuse the data or it can extract or aggregate the data from the sensor field. Okay, that is the purpose of this synchronization protocols. So this what to say, in addition that these protocols or these sensor nodes may be self-organized, the sensor nodes into cluster to compute the task or to overcome certain obstacles. Okay, actually, in short, the sensor networks may provide end user with intelligent details. Okay, where the traditional static sensors may not be able to provide. Okay, so this sensor node communicates through the wireless medium, protocols, and algorithms. Okay, and uh, already I told you about the wireless ad hoc network, right? So the sensor nodes communicate through wireless medium, protocol, and algorithms proposed for traditional wireless ad hoc networks. Okay, that are not suitable for the sensor network. Okay, understood what I said? No, I'll repeat it. Actually, we have some algorithm for traditional ad hoc network, right? So those algorithm protocols will not work for this wireless sensor network. Though this wireless sensor network become a part of ad hoc network, these algorithms specially designed for ad hoc network will not work out for sensor network. Now is it okay? So the difference between sensor networks and ad hoc networks. Already I told you the difference between sensor network and ad hoc network. Anyway, I'll repeat the same. So the number of sensor node in the sensor network can be very high, right? That is several orders of magnitude higher than the nodes in the ad hoc network. Suppose in ad hoc network, if you are placing 50 nodes, in a sensor network, we'll be deploying 500 sensors. Okay, so the number of sensor nodes in a sensor network is higher than the nodes in the ADAC network. Okay, that is one difference. And the sensor nodes are densely deployed. But in ADAC, it is not densely deployed, right? And the sensor nodes are prone to failures. But ADAC, it is not prone to failures when as like sensor nodes. Okay, ADAC is also prone to failure, but very, very less when compared to sensor. Okay. And the sensor network topology which changes very frequently. Okay, and sensor nodes mainly use a broadcast communication paradigm. Okay, but this ADAC node, it will always use point-to-point communication. Okay, ADAC network is based on point-to-point communication, but sensor is broadcast communication. Okay, and the sensor nodes are limited in power. Sensor nodes are limited in power, computational capacities, and memory. Okay, sensor nodes are limited in power, computational capacities, and memory. And these sensor nodes may not have global identification, global ID. Sensor nodes may not have this global ID because large number of overhead and large number of sensor nodes. So number of nodes increases, naturally the number of overheads increases. So because of that, we are not providing each node with a global identification, global ID. Okay, but ADAC, it's not like. Sensor networks are deployed with specific sensing application in mind. Okay, but ADAC network is for common communication purpose. But sensor network, suppose in this area, temperature means temperature alone. Moisture content means moisture alone. Okay, then the type of the soil, only type of the soil alone, like application specific. Okay, that is, so these are the difference. So with these differences, the design of communication protocols for sensor network requires specific attention. Okay, so some of the potential application, and there are some application layer protocols are there. So application layer protocols is a separate topic for you. Application layer protocol topic is there, transport layer protocol is there. Before that, this time synchronization protocol. So first we will study time synchronization protocol, then we'll go for transport layer protocol as well as this application layer protocol. So this time synchronization protocol, that is, instead of the time synchronization between the sender and receiver during a specific application like internet, here the sensor nodes in the sensor field first must maintain a similar time with certain tolerance throughout the lifetime of the network. Okay, so in normal communication, the synchronization is between only the sender and the receiver. Okay, that you might have studied the synchronization in digital electronics, that if you give synchronized clock pulse to the center, you'll be to the that kit, you have done it, right? So if you give a clock pulse, you'll change, the output will change. Again you give clock, output will change. That is, there will be a synchronization between your sender and the receiver. But here, instead of synchronization between sender and the receiver, all the nodes in the network will have some synchronization. That is, it will have some similar time within the tolerance period. Okay, throughout the lifetime of the network. So here, sensor node must be energy efficient, low cost, and small in multi-hop environment. Okay, so these requirements offer a challenging problem for the wireless sensor network. So these sensor nodes may be left unattended for a long period of time. Example, in deep space or on the ocean floor, it may be unattended for long period of time. So for short distance multi-hop broadcast, data processing time and variation in data processing time may contribute most of the time fluctuations and differences in the path delays. Okay, so small and low-end sensor nodes may exhibit the device behavior which is worse than those of the large system. Okay, so I'll tell you some factors which influence the time synchronization in large system. Okay, so the factors which influence the time synchronization in large systems are: first one, temperature. Okay, second one, noise. The third one, delay. Fourth one, clock. Here we'll be telling it as clock glitches. Okay, so temperature, I'll explain about temperature. I'll explain these four factors, remaining we'll see in the next class. Okay, so temperature, because sensor nodes are deployed in various places, naturally the temperature variation will be there, right? So the temperature variation throughout the day may cause the clock to speed up or slow down. Okay, so for a typical personal computer, the clock drifts few parts per million during the day. Okay, this is one research data. The clock drifts few parts per million during a day. So for low-end sensors, the drifting time may be even worse. Okay, this is for high-end. Okay, so next is noise. So they have classified the noise as two types: phase noise and frequency noise. Okay, they have classified the noise into two types: phase noise and frequency noise. So some of the causes of phase noise are due to the access fluctuations at the hardware interface. Okay, access fluctuation at the hardware interface, and response variation of the operating system to interrupts, and jitter in the network delay. Then, okay, these are the causes for phase noise. And frequency noise, the frequency noise is due to the instability in the clock crystal. Okay, so the low end crystal may experience large frequency fluctuations. Okay, the clock it will create large frequency fluctuation. So this is about the noise. Temperature, the noise. Noise, there are two types: phase noise and frequency noise. Then asymmetric delay. So delay will here this asymmetric delay. So sensor nodes communicate with each other through wireless medium, right? So the delay may be based on the path it took. Okay, so since sensor nodes communicate with each other through the wireless medium, the delay of the path from one node to another may differ from the return path. Okay, so it will take one path and return different path it will be taking. Depending upon the path length, the delay will occur. So as a result, this delay may cause an offset to the clock that cannot be detected by variance type method. Okay, so asymmetric delay is static, then the time offset between the two nodes are also static. So if the asymmetric delay is bounded by 1/2 the round trip time between the two nodes. Okay, round trip time is nothing but when one data is transmitted from sender to node and from sender to receiver, and the acknowledgement from receiver to sender. Okay, the complete rotation is called as one round trip time. Okay, so next is clock glitches. Clock glitches are nothing but the sudden jumps in time. Okay, this may be caused by hardware or software anomalies. We have studied the anomalies, right? Hardware anomaly and software anomalies, such as frequency and time steps. Okay, clock glitches are nothing but the sudden jumps in time that may be caused by hardware or software anomalies like frequency and time steps. Okay, so this protocol, I'll explain it in the next class. So these are the causes for the time synchronization. These are the factors which influence the time synchronization protocols. The factors which influence the time synchronization protocols are temperature, noise, delay, and clock glitch. Okay, noise, here there are two types: phase noise and frequency noise. Okay, and delay will be calling it as asymmetric delay, and clock, it is clock glitch. Okay. I'll take the attendance now. Ajay?
Present, ma'am.
Abhishek?
Present, ma'am.
Jeevan?
Present, ma'am.
47. Present.
Present, ma'am.
Okay. Andrew Michael?
Present, ma'am.
Sherwin?
Present, ma'am.
Sherwin. Okay, ma'am. Amarnath? Amarnath? 73.
Ma'am, chat box.
Okay, ma'am. Okay. Govardhan? Govardhan 77.
Chat box.
Okay, ma'am. Nikita?
Present, ma'am.
Bijo?
Present, ma'am.
Hariharan?
Present, ma'am.
Kingsley?
Present, ma'am.
Jaswin?
Present, ma'am.
Jaswin?
Present, ma'am.
Okay, ma'am. Julian?
Yes, ma'am.
Patrick?
Present, ma'am.
Kevin?
Present, ma'am.
Sanjay? Prince?
Present, ma'am.
Hema?
Present, ma'am.
Pallavi? Pallavi? Pallavi is here? இருந்தாங்களே.
Her device got stuck, it seems, ma'am.
Okay, ma'am.
Ma'am, 47 present, ma'am.
Okay, ma'am. Okay. All present today.
Yeah, thank you, ma'am.
Okay, ma'am. Okay. Thank you. Thank you for attending.
Ma'am.
Yes, Pallavi. Yeah.
Ma'am, can you upload to